What is the one thing that college students need the most but never seem to have enough of? Time.
According to various studies, it is estimated that students spend an average of 3 hours doing homework and 3 hours in class per day. Many students also work part-time, averaging another 3 hours per day, with clubs or sports taking up an additional 2 hours. This adds up to 11 hours per day solely on school-related activities, not even including transportation and other daily routine tasks.
Before we know it, literally half of our day is gone, and we realize we haven't had time to eat yet. The NIH has reported an average of 45% of young adults skip at least one meal per day, with lack of time being the main reason.
Since many on-campus food locations are quite far away from academic buildings, many students don't have enough time to fit getting food into their schedules. But what if our food could be brought straight to us? Introducing Robert, the autonomous delivery robot. Starting out as a collaboration between RIT and D3 Embedded to create a test bed for different vision technologies, Robert could easily redefine the future of college campus dining.
Hi, I'm Scott Reardon, CEO and founder of D3 Embedded. The autonomous delivery robot is a great collaboration between RIT and D3 Embedded. Beyond the current project, using it as a food delivery robot, this robot's modular design will allow D3 to use it as a platform for testing various cameras and sensors, also to be able to demonstrate autonomous technology at trade shows. This project has potential to showcase both the innovation at RIT and D3 Embedded, and hopefully spark advancements in the autonomous technology space.
Now we'll get into the specifics of the robot. Robort uses an NVIDIA Jetson AGX Orin for all primary processing and a Texas Instruments microcontroller for subsystem processes like driving and battery management. In order to drive autonomously, input is taken from a SICK LiDAR, DF Robot IMU, 2 D3 embedded cameras in a stereo configuration, and 2 D3 embedded millimeter wave radars. Mechanically, Robort has a dual motor 4-wheel differential chain drive setup, which allows for efficient maneuverability. It also has a wireless controller module for manual control via an Xbox controller, which is used for testing and environment mapping. Robort also features a large payload container which has 2 separate compartments. One houses the cameras and sensors used for driving, while the other is an open space where food will be placed for deliveries. Now onto autonomous driving. The robot uses the SICK LiDAR to map out its surroundings during operation in any given environment. A user can manually drive the robot around and allow it to create a map, or have it create the map during autonomous driving. Data from both the LiDAR and IMU are combined to accurately map out the operating area. Onto the ADR flowchart. After power up, the user chooses which mode they want. If they want manual mode, it is initialized and the user can drive the ADR via an Xbox controller. If autonomous mode is chosen, then the sensors including the LiDAR and mono cameras will be initialized, and then the ADR system will wait until a destination is given. When a destination is given, the ADR autonomously navigates its environment to the given destination and waits for someone to access the payload with the password. Once the payload has been accessed and the door is closed, the ADR will navigate back to the charging station autonomously and wait for the next destination command.
Now, onto more mechanical details. Robort was specifically designed to be modular, featuring many adjustable rails and mounts. This approach allows the robot to function in various environments for different purposes. All sensors can be easily added or removed depending on operation needs. The orientations of these sensors can also be easily changed, allowing for fine-tuning of the system. The payload container discussed earlier features a sliding door to provide students access to the food compartment. The sliding door consists of a belt and pulley system driven by electric stepper motors. The door itself has attached casters that glide in rails as the belt pulls it open and closed. After a student receives their food, Robort will then return home to its charging station, where batteries are charged until a new order is received.
Robert features 6 lithium-ion polymer batteries, separated into 2 battery packs. These batteries are charged wirelessly through induction to increase the efficiency of the overall robot operation. One inductive coil is attached to the underside of the robot, while another is attached to a charging station. The batteries will automatically start charging once these inductive coils are aligned. These inductive coils must be aligned perfectly to maximize charging efficiency. To ensure perfect alignment, a charging station was developed that allows Robert to easily and reliably drive into the proper position for optimal inductive charging.
In addition to inductive charging, Robert has many unique features. Robert can operate autonomously both indoors and outdoors, with intentions of a seamless transition between the two. This is possible due to the combined use of cameras and sensors, operable in any environment. Robert can even operate in poor weather conditions, as it is waterproof rated to IPX3 and has heavy-duty tires with good traction. Robert is also portable due to the modular design, and of course, it has built-in safety features such as emergency braking.
As a full-time student, I'm in classes from 9 to 6 p.m. and then I have clubs afterwards. I do not have time to go and buy dinner some days. It would be incredible if a delivery system existed that could provide me the food I need to improve both my academic performance in addition to my health.
Therefore, Robert can help alleviate some of the stress college students face by giving them more opportunities to eat. Colleges can also benefit from increased dining sales and even the creation of more technology-focused part-time jobs for students, as someone will need to take care of Robert. Overall, we look forward to Robert, the autonomous delivery robot, making college campuses healthier and more student-focused places.